Okay, so now we're going to do this problem. It says the angle theta lies in the second quadrant, and sine of theta is 3/5. Now, the quadrant, they tell us the quadrant because it matters in the sense of what's positive and what's negative, right? So the x comma y, depending on what quadrant you're living in, your x or y could be positive or negative. A perfectly drawn xy plane here. All right, so let's label this bad boy. This is quadrant 1. This is quadrant 2. This is quadrant 3. Quadrant just means that you're dividing it into 4 equal parts, right? And so they're telling us that our triangle, our right triangle lives here, where this is the angle theta. The side across from the angle theta is the opposite. The side across from the 90-degree angle is the hypotenuse. And then the side left over is the adjacent. Adjacent really means touching, okay? So it's touching the angle theta. Now this point here, we often think of as x comma y, but because it's in the second quadrant, my x value is negative and my y value is positive. But to get that, think of it like this. My adjacent, right, is going to be the x. So I have a negative adjacent value, and I'm going to have a positive opposite value. Okay. So we're going to, at some point, we're going to do the Pythagorean theorem to find the leg. And then when we take that square root, we have to decide if we're going to go with the positive or negative value. So let's label this. Sine of theta, if you think of SOHCAHTOA, that's horrible handwriting. It's so hard to write on one of these things. SOHCAHTOA, that means that sine of theta is equal to the opposite over the hypotenuse. Ka means cosine, right? So we have sine opposite over hypotenuse. Cosine, that's what the C stands for, is equal to the adjacent over the hypotenuse. I don't know who originally came up with this, but it's such an easy way to remember this, SOHCAHTOA. And then tangent is the opposite over the adjacent. And they're telling us that sine is 3/5. So that means that my opposite is 3 and my hypotenuse is 5. And we got to figure out what the adjacent is. But whatever it is, it's going to be negative. So again, we use the Pythagorean theorem. We're used to seeing a squared plus b squared equals c squared. But that really is the opposite squared plus the adjacent squared is equal to the hypotenuse squared. So if my opposite is 3, and I'm solving for the adjacent, and my hypotenuse is 5, then I get 9 plus a squared is equal to 25. I'm going to subtract 9 from both sides. I get that the adjacent squared is equal to 16. I'm going to take the square root of both sides. Remember, whenever you take the square root of something, you have a plus or minus. Why do you have a plus or minus? Well, 4 squared equals 16. But if I say negative 4 squared, that's the same as saying negative 4 times negative 4. That also equals a positive 16. That's also why we can never take the square root of a negative number, because no matter what you square, it will always be positive. You can never square a number and have it be negative, not a real number. So we're going to choose the negative 4. Why? because this thing lives, the distance from here to here is -4 because we're going in the negative x direction to get to this point here. In other words, this point right here is -4, comma 3. Okay. Well, what they wanted us to do is write down what cosine of theta is. Well, cosine of theta is the adjacent, which is -4, over the hypotenuse, which is still 5. And then they also wanted us to find tangent. Well, that's easy. Tangent is the opposite, which is 3, over the adjacent, which is -4. And so basically, those are the two solutions to this thing. Oh, shoot. And that's what they wanted us to find.